We are now almost ready to start adding animations, but before we go ahead and do that, we'll first fix a few existing bugs. The first bug we have is due to gravity. This bug happens when we are near an edge and our capsule collider starts falling due to its spherical bottom. This basically makes our player fall and also adds a bit of velocity due to physics. This is a problem because this can happen in the states where we are standing still, like the idling state or the landing states, as it makes our player slide while we were supposed to not be moving, due to the velocity it added when falling off the edge. The fix for this bug is quite simple. If the player is moving in one of these states, we reset its velocity. Thankfully for us, we already have two methods that allow us to do just that. We only need to fix this problem in three states, which are the idling state and the light and hard landing states. Knowing that, start by opening up the player idling state script. In here, override the physics update method. Then type in if not is moving horizontally, and if that's the case, we return. In the case that it is moving though, we simply call in reset velocity. And that's all we need to do. So now copy this whole physics update method and go over to the player light landing state script. In here, paste the physics update we have just copied into the iState method's region. Then do the same for our player hard landing state. We won't be doing this in our player landing state because our rolling state doesn't need it. That solves one bug, but we still have a few more to fix. The next one is regarding our dashing state. I thought I had fixed it, but turns out that there's still one bug, which happens when we move, dash and then unpress the movement key. It doesn't always happen, but when it does we simply dash at a low speed. I'm not entirely sure why, but it's likely because we are using the movement speed in this dash, and we just changed to a low speed modifier state. I've changed the code a bit and hopefully it is enough to fix it. But in short, we'll simply always add an initial force when dashing. To do that, open up the player dashing state script. In here, rename our add force method to dash instead. Because we'll be adding a force in case we have a movement input as well, place the current code that guesses the direction above our if statement and remove the return statement. Inside of our if statement, we'll now call in update target rotation and pass in get movement input direction. This will simply update our target rotation to be relative to our movement input and camera, which will allow us to add a force towards that direction. Then we'll set the character rotation direction to be equal to get target rotation direction and pass in state machine .reusabledata.current target rotation.y, which will get us the direction of our input relative to the camera, as we have just updated it. Of course, our character rotation direction variable name no longer makes sense, so I'll rename it to dash direction instead. From what I've tried, it seemed to work without this whole if statement, but I'll leave it as is, as it makes more sense and to make sure it doesn't cause any rotation bug. With this, we are now always adding a force to our dash towards a certain direction, which depends on whether our movement input is being pressed or not. This should be enough to fix it. However, we also need to take into account the movement speed on slopes, as right now we'll be dashing slower when we are on a slope. So, go to the get movement speed method in the player movement state script. In here, add a new parameter by typing in bool should consider slopes defaulted to true. Then create a new variable by typing in float movement speed and assign to it the first multiplication. Then we'll check if should consider slopes, and if that's true, we type in movement speed multiplied by state machine reusable data movement on slopes speed modifier. At the end, we update the whole return statement to return this movement speed variable instead. When that's done, go back to the player dashing state script and pass in false to the get movement speed method. And that's another bug fixed, so for the next one, I've previously added a Mathf.Abs when falling in case we fell into a ground that was above our current ground. However, that's of course not valid, as if we ever fall in such a situation, we don't want the player to go to the hard landing state or the rolling state, but only to the light landing state as the ground is above the player. To fix that, open up the player falling state script. In here, in our onContact with ground method, where we transition to the landing states, remove the Mathf.Abs from the fall distance variable. We'll now always transition to the light landing state in the cases we have just mentioned. That's all we need for this one. So for the next one, I've also previously said that we didn't need to update the target rotation when we jumped and add input. But with the addition of our landing states into our system, that's no longer the case. This is because our light landing state does not allow movement, which means that our target rotation will never be updated. This makes it so that if we start jumping to one side and we press the opposite side key in the middle of the jump, and then jump while in the light landing state, we will keep jumping towards the old direction. To fix that, open up the player jumping state script. In the jump method, inside of the first if statement, before assigning our jump direction a new value, type in update target rotation and pass in get movement input direction. This updates our target rotation to be relative to our input and the camera, so replicating the situation we have mentioned before should now work correctly. That should be enough, but we now have one final bug to fix. This bug has to do with our falling state. You might have noticed sometimes that when we fall from a ramp, we don't enter the falling state. The problem lies in that we are using the bounce.accents variable to set the size of our overlap box. Apparently, Unity changes this variable, which means its values can become something we don't want. I'm not entirely sure why, but according to this post, it's because the bounds are cubes in Unity, and therefore when we rotate, it will change the extents. Our Capsule Collider vertical extents property is fine, because we are using a cached extents. So even if it changes at runtime, we are not getting that one but the initial extents. For our overlap box bounce.extents though, we'll have to cache it. Thankfully, we already have a reference to our box collider, so we can easily do that. To do it, open up the player trigger collider data script. In here, add in a new property by typing in public vector3 ground check collider extents and give it a private set. Then create an initialization method by typing in public void initialize. And inside type in ground check collider extents equals to ground check collider dot bounce dot extents. Of course, we need a way to call this method, so open up the Capsule Collider utility script. We could override the initialize method, but we return here if the collider is already initialized, so we'll create another method instead, which we'll call here. So, under our initialize method, create a new method by typing in protected virtual void onInitialize and leave it empty. Then call it at the end of our initialize method. Back to our player Capsule Collider utility script. Now override the onInitialize method and call in trigger collider data.initialize. If you use composition, then you will simply create an initialize method here and call both properties initialize methods inside. We now need to use this new extends property, so open up the player grounded state script. In here, go to the main methods region to our isThereGroundUnderneath method. Inside, swap our groundCheckCollider.bounce.extends with stateMachine.playerColliderData.triggerColliderData.groundCheckColliderExtends. Our bounce.center is alright because we want the center at the time we check for the ground. This should be enough to fix our bugs, so saving it all up and going back to Unity, all of our bugs should be solved. Of course, some of them were only visible with animations due to the animation transition events.